this session, we are going to discuss very important sum. Let's start. Given tan A is equal to 4 by 3. Okay, so one ratio is given. Tan A is equal to 4 by 3. Tan of angle A. Remember, do not multiply it, right? Find the value of other trigonometric ratios of the angle A. Remember, they are asking the ratios of angle A only. One ratio is given for angle A and we need to find remaining 6 ratios for the angle A as well. So let's start. First of all, tan A. Let's write over here that tan A. Tan A is equal to 4 by 3. This is given. Done. Now, if you draw the figure, it is really helpful to get the value of other ratios. Try to do that. And remember, we always draw the right triangle. We are talking about hypotenuse here. So, we need to draw right triangle. This is 90 degree. This is angle A. Here, angle A it is, right? And we have hypotenuse, we have AB, we have BC. But what we are most interested in is opposite side and adjacent side. Hypotenuse is going to remain as it is. So this will be your adjacent. Then which is the next? This will be your opposite. Why opposite? Think. This is your opposite side. Opposite to what? Angle A. Opposite side to angle A and opposite and adjacent side to angle AB. Then what are we missing? We are missing the hypotenuse. So let's write the value of hypotenuse. Hypotenuse. Done? So hypotenuse done, adjacent done, opposite done. Now let's use this information to get the value of remaining ratios. Let's start. Tan A is equal to 4 by 3. So first of all, what is tan A? What is the formula for ratio tan A? Let's recall that. Tan A, it means that yes, opposite over adjacent. It is opposite over adjacent. So let's write here tan A opposite over adjacent. Done. Now, will I be writing 4 and 3? No, because it is given ratio. Now, ratio can be in two forms, either simplified or either not simplified. Let's say I am writing a number 10 by 15. Remember, 10 by 15 here 2, here 5 2s are and 5 3s are. So, ratio is 2 by 3. This is the simplified form. This is simplified form. When I have this value, I cannot know this value, which is 10 by 15. I can guess it that some number is multiplied with 2 and the same number is multiplied with 3 as well. Like in this case, it is 5, right? And I am getting this value 10 by 15. So when I get the ratio, I am not getting this value which may be multiplied with numerator and denominator. So whenever we have this case, we are going to write as k, or you can also write x here as well. So here it will be 4k and 3k. Remember, 4k and 3k we are taking as k because we don't know this k. This is an example to understand that 5 we have multiplied, but that is not the case always. We do not know it. So for that we need to take 4k and 3k. Now let's substitute the values. So which is the opposite side? Opposite side is BC. Okay, so BC. And what is the adjacent? Which is AB is equal to what? 4k by 3k. So can I write over here that adjacent side is what? 3k. This is 3k. And another is opposite side, which is 4k. So this is 4k. Done. 3k and 4k. But when you see into the ratio, you need to use hypotenuse as well. Let's talk about the sine A. If I want to find sine A, I need to have ratio says that opposite over hypotenuse. So opposite side I have it, but what is missing? Hypotenuse. So to find those ratios, we need to have value of hypotenuse. So how to get the value of hypotenuse? Think. Very simple it is. Pythagoras theorem. We are looking for the relation of sides of right angle triangle. In this case, we are going to use Pythagoras theorem. We know whenever right triangle is coming, we always discuss the Pythagoras theorem. So with the help of Pythagoras theorem, I am going to find the value of AC. After that, I will be having value of all three sides. Very simple, all three sides, and I need to just substitute the value into the ratios to get the answer, or to get the ratio or get the value of all the remaining ratio. Let's do the Pythagoras theorem first. So Pythagoras theorem. Okay. Now here I am writing directly, which is hypotenuse square is equal to opposite square plus adjacent square, or I can write here as AC square is equal to AB square plus BC square. Now I don't have value of AC because I want to find that value. I have value of AB, which is 3k whole square, plus BC, which is 4k whole square. So here it is 9k square, 4 square, 16k square, and if you add, you will be getting 25k square. This is value of AC square, but I want the value of AC. So to get the AC, you need to take square root of 25k square. So square root of 25, 5 only, and square root of k square, which is k only. Remember, we are only going to take positive value. We are talking about the side of triangle. Side of triangle cannot be negative. Remember. So 5k over here, done. So my value of hypotenuse is also with me, which is 5k. Now what I'm going to do, I'm only going to substitute these three values where I need to use in the ratios. So let's start. Let's start with this sign first of all. So sine of A, or sine A, which is, what's the value? Opposite over hypotenuse. So opposite over hypotenuse. Now what's the answer? Opposite is what? 4k. Yes. What is the hypotenuse? 5k. K will get cancelled. So what's the value of sine A? Which is 4 by 5. That's my first missing ratio. Let's find the second one. Now we are going to find the next, which is cos. So cos A here is equal to, what's the ratio? You can see over here, which is adjacent over hypotenuse. So let's write adjacent over hypotenuse. So adjacent, what's the value of adjacent? 3k, very simple. Then what's the value of hypotenuse? Which is 5k. And let's cancel the k. What's left? Which is 3 by 5. So cos A is equal to 3 by 5. That's my second ratio. Done? Very simple. Third was tangent, but it is already given. Now we need to find cotangent. So let's find the cotangent, which is cot A, or let's write cot A is equal to, what's the formula? It's given over here, which is adjacent over opposite. So adjacent over opposite. Done. Now let's substitute the values. Adjacent value is what? 3k. Good. And opposite value is what? 4k. So let's cancel k, and what's the answer? Which is 3 by 4. So value of cot A, which is 3 by 4. Now two more ratios are left. Can you do on your own as well? Very simple. This question is asked many times in exam, maybe 1 mark or 2 mark. You need to guess the value and quickly. Most of the times, if numbers are coming as a 3, 4, 5, you already remember that is a Pythagorean triplet. They always come together 3, 4, 5 and it form a right triangle. If 3 and 4 is coming, just calculate in your mind that 5 is the hypotenuse. So it is easy to do the calculation and quick. Okay, let's find the cosecant. Cosec A is equal to what? Hypotenuse over opposite. So hypotenuse over opposite. So what's the value of hypotenuse? Value of hypotenuse 5k and opposite is 4k. So it is 5 by 4. Cosec A. Done. Next, sec A. Let's find the last one, which is sec A. Sec A, which is what? Hypotenuse over adjacent. So hypotenuse over adjacent here. Then what is the value of hypotenuse? 5k. And what's the value of adjacent, which is 3k? K will get cancelled. So what's left? 5 by 3. That is what? Sec A. Remember, sec A. So my 5 ratios are here. One was already in the question. So this is how we find the remaining ratio when only one ratio out of all trigonometric ratio is given. Let's recall the step. First of all, tan A is equal to 4 by 3. I applied the formula, which is opposite by adjacent. So 4k by 3k, I get the value of adjacent and opposite. But in ratios, we need hypotenuse as well. So fine, with the help of Pythagoras theorem, if any of the one value is missing, you can find always with the help of Pythagoras, not only the hypotenuse. So now we have all the three values. You have formula of the ratios, substitute and get your final answer. So this is how we find the missing ratio of trigonometric values when only one ratio is given.